Alright, in today's lesson we're going to be looking at solving trigonometric equations. So our first one here is the root of 3 cos x minus sin x is 1. Again, the focus of this lesson will be these trig equations. Some of these will require identities. Alright, so if I want to solve this trig equation, you want to look for a GCF, some way to factor this, but you'll notice I have nothing to GCF out here. If I bring the 1 to the other side, we don't have a quadratic, nothing like that. So a common technique when you see something of this form, where it's a cos plus or minus a sine equaling some value, what you can do is you can square both sides of the equation. Squaring both sides, we get the following. All right, squaring both sides, we get the following: 3 cos squared x minus 2 root 3 sine x cos x plus sine squared x. Now, in this situation here, we're still looking to factor something out, but I don't have that going on here. What I'm going to do, though, is make the observation. I have 3 of these cos squareds of x's. What I can do is I can take apart one of them, leave me with 2 of these, and I can combine that with a sine squared x to give me 1. Let's rewrite that and take a look. And you can see here I took one of the cos squared x's, I moved it over here, and we know that's going to sum to be 1. This will end up equaling 1, and then when I subtract 1 on both sides, we'll end up getting 0. Simplifying, we get the following. And you can see here the 1's cancel off, and I'm left with this. Now I can go ahead and factor out a 2 cos of x, giving us. And therefore, we have 2 options. Either the cos of x is going to be 0, or cos minus root 3 sine of x is going to be 0. Let's take a look at solving both of those equations. All right, so like we were discussing, cos of x is 0, or cos minus root 3 sine of x is 0. Focusing our attention on the cos of x equaling 0, we have the following. So when theta equals pi over 2 or 3 pi over 2, we're going to get the cos of x equaling 0. On the right-hand side here, we want to go ahead and solve this equation here. So to solve the following trig equation, what I'm going to do is I'm going to divide across by the cos of x, giving us 1 minus root 3 tan of x. Again, by dividing across by cos of x, I'm assuming that cos of x is not equal to 0. If cos of x was equal to 0, we've already covered that condition on the left-hand side. So it's safe to assume that cos of x is not equal to 0, because if it was, we already have those values identified here. Now isolating for the tan of x, we get solving for x gives us, we end up getting x is pi over 6 or 7 pi over 6. All right, we have to be careful here. Now that we do have our complete list of answers here, some of these could be extraneous roots and actually not be a solution. Because we did square both sides, we introduced the possibility of that. So all 4 of these need to be checked in the original equation, ensuring that they are in fact a solution. Checking in the original equation, we get the following results. So again, the original equation we started off with was the root of 3 cos x minus sine x is equal to 1. Checking for x equal pi over 6, we get a solution, and that value is equal to 1, so pi over 6 is in our solution set. If I check at pi over 2, we end up getting a minus 1, so this is not a solution. Checking at pi over 6, we also get a minus 1, and this is, again, not a solution. Those are 2 extraneous roots. And lastly, checking at pi over 3, we end up getting this is in fact a solution. So the actual answers here are going to be pi over 6 and 3 pi over 2. All right, let's take a look at our next trigonometric equation. All right, for the following trig equation, we have 3 cos 2x plus sine x is 1. Again, we'll keep that domain between 0 and 2 pi in radians. So right away, you're going to want to look at choosing some trig identities to solve this here. Now, if you take a look here, the cos of 2x has 3 different formulas. One is cos squared x minus sine x. The other is 2 cos squared x minus 1. And then lastly, 1 minus 2 sine squared x. We're going to want to use that last one, because then you have a function all in sine of x and the possibility of getting a common factor or factoring and being able to solve this equation. So go ahead and doing that substitution, we get the following. Now we can go ahead and distribute that 3, simplify, and bring everything to one side, which will give us. And you can see here I distribute that 3 into the brackets. I then simplified, putting together the 3 and when I brought that 1 to the other side, you end up getting a 2, multiplied across by minus 1, and we have ourselves a quadratic. Let's go ahead and factor this. So going ahead and doing our charting or decomposition, whatever you like, I end up getting 3 sine x minus 2 times 2 sine x plus 1. So the only way that's going to be 0, either the 3 sine x minus 2 is 0, or the 2 sine x plus 1 is 0. This implies sine of x is 2/3, or the sine of x is minus 1/2. Solving these, we get the following. And solving for this here, when the sine of x is minus 1/2, that relates to our 2 spots on the unit circle at 7 pi over 6 and 11 pi over 6. So you have these values in radian measure. And then when sine of x is 2/3, that's not one of our special points on the unit circle, those 16 points. So when you take your sine inverse here, you end up getting your calculator give you 0.73, which is the distance from here to here in radian measure. That'll be one of our solutions. And the other one will be measured as pi minus 0.73. So we're kind of backing that up. If the distance from here to here is 0.73, then here to here will also be 0.73. So this measure is pi minus 0.73, which is approximately 2.41. So putting all these solutions together here, we have our answer. And here are our answers displayed in set notation. All right, that concludes today's lesson on solving trigonometric equations with identities. Thank you.